Hello everyone, welcome to the channel. Today we will learn the maximum and the minimum modulus principle in complex analysis. We will keep it short, simple and with two easy examples, so stay till the end and hit the subscribe if you like it. In this presentation or in this video, we will try to remember first the basic important topic like what is modulus, open set and domain, analytic function before we exactly define the maximum and minimum modulus principle. So first let's try to remember the modulus. For any complex number z, we know that the modulus of z is its distance from the origin. Let's say for example, if z is a complex number which is 3 plus 4 iota, then its modulus of the z is square root 9 plus 16, which gives you 25. Square root of 25 means 5. So in this topic we don't care about the exact value of z, we care about how big or small the modulus of the function can be in a region. So the next topic is open set and domain. It means we usually apply this principle in a domain. A domain is a connected open set, like a circle or a disc without the boundary inside it. So imagine a region with no hole and no gap where the function is defined everywhere. That's what we mean open set or a domain. So the next topic is about the analytic function. We know that the key idea works only for the analytic function. An analytic function is one that is differentiable in a whole region. Analytic functions are smooth and don't have sudden break, so their modulus behave in a very special way. So this is the main our focus for today, maximum and minimum modulus principle. So what do you mean by the maximum modulus principle? This principle says if the function fz is analytic and not constrained in a domain D, then its modulus of the function cannot have a maximum value inside the domain D. That means the largest value of the maximum or the modulus of the function must happen on the boundary of the domain D, not in the interior of the domain. So these are some of the important points. Here it means that if the modulus of the function has a maximum inside the region, let's say if the function has the maximum inside the region, then the function would force to be constant in that region in the whole domain D. It means analytic function don't allow peaks in the middle, means inside the domain, unless they are constant everywhere. So maximum must be on the boundary. Similarly, here is this, the minimum modulus principle. It is also if function is analytic and never zero in a domain D, then the modulus of the function cannot have a minimum inside the domain D. So obviously the smallest value of the modulus of function must also occur on the boundary, not inside the region domain D. So let's consider some easy examples in the following. The example number 1 is related with the modulus, maximum modulus. So let's take a simple example. Let's say the function is equal to z on the unit disc, modulus z less than equals to 1, which is unit disc. Then modulus of the function will obviously equal to the modulus of the z. Inside the disc, this modulus of z is less than 1, and on the boundary this modulus of z is equals to 1. So the maximum of the modulus of function is exactly on the boundary, not inside. This matches the principle because the function is equal to the z which is analytic and not constant. So let's move on to the next page, which is this example is related to the function which is non-constant and a constant one. So now let's take a constant example. Let's say the function is equals to 2 on a unit disk. Then the modulus of the function is equal to 2 everywhere inside and on the boundary. Here the maximum and minimum are same at every point. The principle allowed this only because the function is constant. Again, for non-constant analytic function, these cannot happen inside. I hope you all understand until here. So let's try to summarize. It means if a function fz is analytic and non-constant, its modulus fz has no interior maximum point. It means maximum will occur on the boundary. Similarly, if the function is analytic and never 0, it means it is not constant, then the modulus of the function has no interior minimum point. It means minimum point is also on the boundary. So it means both maximum and the minimum are forced. The A's, it means they are forced on the boundary of the region, not inside the domain. So guys, if this helps you, please like, subscribe and comment if you want a video on related topic like Liouville theorem or Schwarzschild.